So let's talk about trigonometry. Trigonometry allows us to find side lengths and angle measures of right triangles, or even sometimes other triangles, when we don't have enough information to use the Pythagorean theorem or special right triangle ratios to find those values. It also uses concepts that rely on similar triangle relationships. So up here we have a definition. It says that a trigonometric ratio is a ratio of two sides of a right triangle. And there are three trigonometric ratios: sine, cosine, and tangent. The sine of angle A compares the length of the opposite side to the hypotenuse side. So let's talk about that on our triangle here right quick. Here's angle A, right? So which side is opposite of angle A? That would be side BC. So I'm going to put an O here to say that's my opposite. In fact, I'll write the word opposite. Then our hypotenuse is the side that's opposite the right angle. So now I've labeled my hypotenuse as well. And the final remaining side there, that side is considered to be adjacent to angle A. Adjacent. That means it's touching angle A. It's right there. So that's sine. Sine would be the length of the opposite side divided by the length of the hypotenuse. So I'm just going to pretend that I know what these side lengths are. I'm going to say that the opposite is 3 long and the adjacent is 4 and the hypotenuse is 5, just to make things easy here. So what would the sine of angle A be in this case? Well, in our example, it would just be 3 over 5, because the opposite side has a length of 3 and the hypotenuse has a length of 5. So let's talk about cosine for a second. Cosine compares the length of the adjacent to the length of the hypotenuse. So for our example here, that would be 4 over 5. And then finally, tangent compares the opposite to the adjacent. So our opposite is 3 and our adjacent is 4. So tangent of A would be 3 over 4. And these are just useful values that we can use to find angle measures and side lengths. One thing I want to point out is that you'll need to change your calculator to degree mode if you are looking at problems that talk about angles measured in degrees. So figure out how to do that. Depends on what type of calculator you're using, but be sure it's in degree mode. And now just try these ones. Just type these values into your calculator now that it's in degree mode and see what you get. So those are the values that you should get if your calculator is in degree mode. So that was just to check. So let's talk about ways to remember the three trigonometric ratios. So here's a summary of what you really need to remember. Just that the sine of an angle is equal to the opposite side over the hypotenuse, the cosine is equal to the adjacent side over the hypotenuse, and the tangent is equal to the opposite over the adjacent. So that feels like a lot to remember, and what a lot of people like to think about is Sohcahtoa. It's just a mnemonic device to help you remember sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent. Of course, in reality, you're probably going to have a formula chart with you, so maybe memorizing these isn't so important. For example, here's a mnemonic device you might like. Some old horse came a-hopping through our apartment. See what you can come up with. I bet you come up with a funnier one. So let's take a look at when you might use trigonometric ratios. So let's look at this first triangle right here. Our angle that we're looking at is angle A. And the first thing I want to do is label my opposite side, my hypotenuse, and my adjacent side. 5 is opposite because it is across from the angle I'm looking at. 13 is my hypotenuse because it is opposite of my right angle. And 12 is my adjacent side because it's right next to the angle that I'm looking at, that one with a measure of 22.6 degrees. So let's look at this. Type this in your calculator, see what you get. Sine of 22.6. Great. Now type in 5 over 13. 38 hundredths again. They are the same thing. Now try it with cosine of 22.6 and tangent of 22.6. And at the same time type over 12 over 13 and 5 over 12. So in all three scenarios, we find that the sine of the angle is equal to 5 over 13. That's the opposite over the hypotenuse. The cosine of the angle is equal to 12 over 13, the adjacent over the hypotenuse. And the tangent of 22.6 is equal to 5 over 12. So your calculator will give you the exact same value, whether you type in tangent of 22.6 or 5 over 12, because that's what tangent means. So now let's see if we could use this fact to find out some missing side lengths. So here for example 2, we want to know what x is equal to. I'm going to start out by labeling my sides. I know that my angle is here, and I know it's 17 degrees. This would be opposite. This is my hypotenuse because it's opposite the right angle. So x is my adjacent. So what I want to think of is which trigonometric ratio compares the hypotenuse to the adjacent side. All right, so adjacent and hypotenuse, that would be cosine. So I'm going to write that cosine of 17 equals my adjacent over my hypotenuse. And then I'm going to substitute in there x for my adjacent and 9.7 for my hypotenuse. I have an equation, and this is not a hard equation to solve. My goal, just like with any equation, is to get x on its own. So I'm going to multiply both sides by 9.7. And doing that tells me that x is equal to 9.7 times cosine of 17. And you can type this directly into your calculator. Type it in and see what you get. So when I typed that in, I got 9.3. And what that means is that this side length right here is equal to 9 3/10. And here's another example. Again, I have x, and I have a degree measure and a missing side length. And I want to figure out what x is. So I'm going to start by labeling my sides. Opposite of 70 is 5.4. So I'm going to put an O right here. That's opposite of the angle I was given. Opposite of my right angle, I have my hypotenuse. And my other side is the adjacent angle. So here I have an opposite, and I have a need to find my adjacent. So here I'm looking at my opposite and my adjacent. So which ratio compares the opposite to the adjacent? Well, that would be tangent. So I can write that the tangent of 70 is equal to the opposite of over the adjacent, or the tangent of 70 equals 5.4 over x. So in this case, to solve for x, I'm just going to remember that there's really a 1 underneath my tangent of 70 there. That way I have kind of a proportion I can solve. Because remember, your cross products are equal, right? And what that lets me do is write that x times the tangent of 70 is equal to 5.4. Now I can see that all I need to do to figure out what x is divide both sides by tangent of 70. So x is going to equal 5.4 divided by tangent of 70. Try typing that in your calculator. Your calculator should tell you that that's equal to 1.97. So that means that this side right here has a length of 1.97. So before we look at one more example, I just want to go ahead and take a look at the steps that we've been using. So we've basically been following this 4-step process. First, we label the sides of our triangle. We label the opposite, the hypotenuse, and the adjacent based on the angle that we've been given or asked to find. Then we choose an appropriate ratio, either sine, cosine, or tangent, based on which sides of the triangle we're considering. Then we write an equation and then solve that equation. So that's the process we're using. Why don't you pause the video and try doing those 4 steps for example 4. Hit play when you're ready to see the answer. So here's how we use the same process to find this one. We write that the sine of 70 is equal to the opposite over the hypotenuse. That's 8.1 over x. And solving that and typing it into our calculator, we find that the hypotenuse is equal to 8.6, which makes sense. It's a little bit bigger than the other side that we were given. You can also use trigonometric ratios to find missing angle measures. Let's look at example 5 up here. Here we're told that the sine of A is equal to 65 hundredths. Well, if we want to know what A is, we're just going to use the inverse sine function. So what I want you to do now is type this into your calculator and see what you get. If you get 40.5 degrees, then you typed it correctly. Now try the next two. This is what you'll want to type in for these two. This little -1 that we have here indicates that we're finding the inverse of these trigonometric functions. This process allows us to find missing angle measures. Let's try it out here with example 6. So for this problem, we want to find the measure of angle R. So that would be this one down here. We're actually going to use the exact same process that we did for side lengths. So first I'm going to label my sides. Here I have my opposite and my hypotenuse. I labeled the adjacent, although what I'm going to use here are the opposite and the hypotenuse sides. So we know we have the opposite and the hypotenuse, so which trig ratio will we be using? sine. So what I can write is that the sine of angle R is equal to 7, that's my opposite, over 13. That's my hypotenuse. So what you'll want to type into your calculator then is the inverse sine of 7 over 13. And that'll tell you that the measure of angle R is 32.6 degrees. I'm going to go ahead and label that here on my triangle. Okay, let's look at example 7. So for this one, we're wanting to find angle P. Now I'm going to get rid of all the markings that I did before, the opposite and the adjacent and the hypotenuse that I wrote, because now they're going to change because the angle I'm looking at has changed. So what's opposite of angle P? That's side QR. And adjacent to angle P would be side QP. The hypotenuse actually stays the same. That doesn't change depending on which angle you're looking at because it's always opposite the right angle. Okay, so for this one, I have my hypotenuse and my adjacent side. So which trig ratio uses your adjacent and your hypotenuse? That's cosine. So for this, we can write that the cosine of P is equal to our adjacent over our hypotenuse. That's 7 over 13. So what you would type in your calculator is the inverse cosine of 7 over 13. Try it out. And your calculator should tell you that that is 57.4 degrees. So I'm just going to try something to check my work really quick. I now know all three angle measures of my triangle. So 32.6 plus 57.4 plus 90, that's my other angle, should add up to 180. Let's see if they do. And those angle measures do add up to 180, which tells me that I have done my work correctly here. There's one more problem here, example number 8. Why don't you pause the video and see if you can figure out angle Z and angle Y. Hit play when you're ready to see the answer. So here's the equation that you could use to find the measure of angle Z. And here's how you could find angle Y. Once again, I'm just going to see if these add up to 180. So I'm going to add them to 90, and yes, indeed, this adds up to 180. So I know I did my work correctly.